how do I factor using difference of squares? Well, first of all, when am I allowed to use difference of squares? A difference of squares question, for those of you trying to remember what I'm even talking about, would look something like this. So what's the criteria for something to be a difference of square question? Well, it has to be two terms, like this, term 1, term 2. It has to be a difference of those terms, meaning it has to be subtraction. Okay, two terms, subtraction. And both of these terms have to be perfect squares. Now, what do we mean by perfect squares? And again, by the way, this is how you put together that name, difference of squares. Because it's a difference of, well, it only has one difference, there's naturally two terms. So what are perfect squares? For numbers, these are numbers that you can square root and get a whole number. So hopefully in your head. Now, the way I generate them is I do 1 squared is 1, 2 squared is 4, because if I do it this way, I know I'll get perfect squares that I can square root and get whole numbers. 3 squared is 9, 4 squared is 16. Let's go a little bit faster. I think you get the point. If I have a variable though, so if I take a look at this, is this a perfect square? Yes. How do I know if something with variables is a perfect square or not? I look at the exponent. It's all about the exponent. The exponent must be even. Quick reason for why that's the case. If I have an even exponent here, I can say that breaks up into x squared and x squared. So square root of x squared, x4 is, well, x squared times itself could give me x to the 4. Sorry if that was a bit quick. Not all of you might get that, but you can still do the question without it. So how do I then do the factoring? Let's do an example where I ask you to factor, let's say 4x squared minus 9. Let's go through our checks. I have two terms, yes. I have subtraction, yes. Both terms are perfect squares, let's check. The 4, yep. The 9, yep. And this is an even exponent. So that's great. Now that I know it passes, what's our formula for that? Well, the formula for difference of squares is this. If I have an a squared minus a b squared, so again, two terms, subtraction, both are perfect squares, my answer becomes a is at the front of both, so whatever the square root of the first term is goes into the front of both of those, and whatever the square root of the second term is goes into the back of both of those. Now, it's important though to note that one of the signs has to be an addition and one has to be a subtraction. So to factor this, I'm going to do some rough work. I'm going to say, well, what would I get if I square rooted this? Now, I have to square root the 4 and the x squared. So square rooting the 4, I get 2. Square rooting the x squared, I really just divide my exponents by 2. So I get 2x to the exponent 1. And then the 9, well, that one's a little bit simpler. Square rooting the 9 gives me a 3. So my final answer then becomes, I need to have two sets of those. So I need my 2x on the front of both, the 3 at the back of both, and one has a plus, one has a minus. And it doesn't matter, I could have done the minus there or the plus there. That's how you factor using difference of squares for a simpler question. They do get more complicated than that, but there's just your mini math review